Welcome, it's another day with Mr. Miracle. We've been discussing integration for a while now. So today what we'll focus on is integration by substitution or integration by algebraic substitution. So if you have not subscribed, please do right now before we delve into the work for the day. Alright, straight into it. Now in substitution, what you do is simple. You define part of the given function by another function. That will help you to evaluate it. It's as simple as that. Let me demonstrate that with question number 1. We say here that integral x exponential x squared dx. Now, how does substitution work? I will say let u be equal to x squared. So the u, the x, we are differentiating this with respect to x, will give us 2x. Then the x, the u, that is inverting this, will give us what? 1 over 2x. So what do we do next? We substitute this into this equation. But also, we can make the x the subject of the formula here. So the x is going to be equal to, the u goes like this, that is, we multiply u with 1 to give us the u over 2x. So we are going to substitute this here. So we say therefore, integral of x exponential x squared dx is now equal to integral x exponential, we define x squared as what? U. Now the x is what? The u over 2x. So we have the u over 2x. So x cancels this x. We'll be left with 1 over 2. So we bring that out. So with this is going to give us 1 over 2 integral of exponential u du. That means we now have a function of u to integrate. So making our work easier. So this is going to be half. For integrating exponential u, it's an exponential function, so we are still getting what? Exponential u plus what? C. But we know what u is, so we quickly bring it back to be half exponential x squared plus c. This is the answer. So simple and straightforward. So we proceed. We are done with 1. We now go to what? Question 2. For question number 2, we have integral x squared cos x cubed dx. Follow the same method. Let u be equal to x cubed. So the u, the x, should be equal to 3x squared. That means the x, the u, inverting it now is 1 over 3x squared, which means that the x alone, moving this side, will give us 1 over 3x squared du. Now, if we say the u over 3x squared and 1 over 3x squared du is the same thing because it's multiplying the numerator, so there's an invincible or an erasable 1 there, or the coefficient of the u there is 1, so we can let it be that way. Now we substitute here. So we say therefore, the integral of x squared cos u, remember we said u is this, the x is equal to, I'm trying to rewrite this, cos x cube is equal to the integral of x squared cos u. Instead of the x is what? 1 over 3x squared du. The dot means multiplication. So the x squared cancels out. We bring out 1 over 3. So this is going to be 1 over 3 integral of cos u du. So this is going to give us, if you integrate a trigonometric sign such as cos, you get sine. So this is going to give us 1 over 3 sine u plus c. So this should be 1 over 3 sine, what is u? X cubed plus c. This is the answer. Feel free to ask questions, and you can also send in your comments of what you think about the method. So let's solve the last question. So for this, we have integral x root 1 plus x squared dx. So we say let u be equal to 1 plus x squared. So if we differentiate u with respect to x, this becomes 0, so this becomes 2x. As we know, du, or rather the x du, should be equal to 1 over 2x. That is the x alone now. This one moves this way, becomes what? 1 over 2x du. So we are now substituting here. So we say therefore the integral of x root of 1 plus x squared dx should be equal to the integral of x u raised to the power of half. Of course, square means, the square root means power of half. So this is u raised to the power of half. Instead of the x, we replace this, which is half x du. So x and x cancels out, we are left with half. Okay, let's use the other side of the board. So we are taking half out, we have half integral of u power half du. So this is now a function of u. So how do we solve this? The normal way of integrating. So this is going to be half u power half plus 1 all over half plus 1 plus c. So here we just need a little bit of arithmetic to solve. So we have half. This is going to give us u. The LCM here is 2. So 2 divided by 2 is 1. 1 times 1 is 1. So we have 1 plus 2 divided by 1, because there is an invisible 1 here, is still 2. 2 times 1 is 2. So this is this. All over 1 plus 2 over what? 2 plus c. So this is going to give us half. This is now 1 plus 2, which is 3. So we have u raised to the power of 3 over 2 all over 3 over 2 plus c. So this should be equal to half u divided by 3 over 2 plus c. So this is equal to half u times 2 over 3. Now, previous class, I already explained why it inverts. It's the law of indices. So after inverting this, you discover that 2 comes to this side. Okay, let's write it. This will be now, since this is multiplying, this can multiply the numerator. So we are going to be having 2u over 3, or these 2 times 3. So these 2 cancels these 2. U here should be 3 over 2. Sorry about that. 3 over 2. 3 over 2. So this will give us what? 1 over 3 u power 3 over 2. But we know what u is. Our u is 1 plus x squared. So this is now equal to 1 over 3. 1 plus x squared, all raised to the power of 3 over 2. This is our answer. Thank you for watching this video. And if this video was helpful, I want you to give it a thumbs up so that YouTube may recommend it to those that may have need for it. See you in my next video. Take care.